that for this part, we're getting away from just a basic quadratic. And in 2.6, they're going to graph rational functions. Now, when you see rational, that's just a fancy word for fraction. So these are fractional functions, if you want to think about it this way. And before they do anything with that one, they kind of back up for just a minute, and they'll have you ask for the domain of the functions, just to make sure that you remember what we're doing here for this part of it. And again, because of how this is going to set up as fractional functions, remember when you find the domain, this is all real numbers. But you're going to exclude the denominator equal to 0. Okay, and they'll give you 2 in the beginning of it just to kind of get you a little bit of practice as you're going through this thing. Now, the good thing with these problems is that on the homework, they should give you a button that says, all real numbers, and then at the end, they'll have something except for x is not going to equal, and then you go back and fill in the blank and just kind of put it in that way. That should be how they set this thing up. So for this one, you're basically going to exclude x minus 4 equal to 0, which again, just going to add 4 to both sides. So you're going to exclude x equals 4. So, and again, I'm thinking back to when with online how this is set up. It should be that it's all real numbers except for x equals 4. I don't think they asked for this, best I can remember. I don't know why they would do this. I'm pretty sure they don't do it in interval notation. If they did interval notation, that would be negative infinity up to 4, and you have to go union 4 up to infinity. Did they do that in 2.6? Okay. Yeah, I knew we've done it earlier, but I think in 2.6 it should be one of those that for the domain they should give you this, and you just have to put the numbers in here. And the other option is that they would give you one that says that there's no exclusion. So it should be one of those, and best as I can remember. And I hadn't looked at it the last little bit. But it seemed like that was the option you get. I don't think they do interval notation, but just in case, we'll go ahead and show it anyway. Alright, we'll do one more of those. Because there's pretty much only 2 options when it comes down to these. They don't get too complicated with the fractions here. So we'll go 3x squared over x squared minus x minus 20. Okay, so again, big thing on this one is that we're going to exclude the denominator equal to 0. And the only difference between this one and the other one was you had the number there, we're good to go. This one you do have to factor it first. And the factoring on these shouldn't be too, these should be pretty straight, easy factoring ones to do. The factors of 20 that would get you down to 1 is going to have to be 5 and 4. And since this number is negative, the bigger number's got to be negative. Other numbers got to be positive. So this one will add 5, and this one will be negative 4. So, and again, I'm pretty sure that the answer is going to be, they'll say that it's all real numbers. And they'll say that x cannot equal, and then you just go back and fill in the blank here and put in the 5 and the negative 4. Just in case they ask for interval notation. Again, I don't think they do, but we'll go negative infinity up to negative 4. Start back at negative 4, we'll go up to 5. going to go 5 to infinity. Yeah, again, I'm almost 99% sure that they don't do this. They'll just give you a blank here, and you go back and tell me the numbers that you've got to leave out. Now, and we've talked about domain I think a couple of times already. So this is one of those where they throw it out to you again just to say, all right, here's a reminder. Here's what we're looking at. Now, here's the big thing. Here's where this ties in, and this is why they hit this again. Those values, those excluded values equal to 0 for the denominator. Those are what we're going to call vertical and asymptotes. That because those are the pots where if you plug those numbers into this function and try to evaluate it, it's going to come up and give you something over 0, which means that that's no solution, right? That's undefined. That's an error message. Your calculator says, no, you can't do that. So here's what we're going to do. Graph-wise, there's not a number there. So that's going to be, they call them all kinds of different things, but basically it's going to be a vertical asymptote. There's going to be a line that we're going to draw right down through the page at that point, and the graph is not going to hit it there. It's not going to be anything that we can do there. So here's what they're going to have you do. And this one's one of those that I can't draw the graph, so this one I'm just going to pull up a homework question. Okay, so I think this will work. So here's what we'll have. Let's say you've got a vertical asymptote, and basically you're going to have a line drawn. It's going to be a vertical line drawn that's dashed. That's going to be a vertical asymptote at -3. This will be a vertical asymptote at 5. And this is just something I'm making up here. What they're going to ask you to do for something like this is they're going to say, all right, we've got this asymptote here, and they're going to ask you, based on that graph, they're going to ask you something like this. What happens when x approaches -3? Now, and they have to kind of differentiate, because if you're coming at -3 from the left side, the graph is going to go down. If you come at -3 from the right side, the graph is going up. So what they're going to have you do on this part is they're going to give you either a plus or a minus. Minus means you're coming from the left, and a plus means you're coming at it from the right side. Because basically, you know, here's your negatives over here, here's your positives over here. So for this one, if you approach -3 from the left side, so you're going to get close to -3, this one's going to keep going down, 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 down. So this one basically would be -infinity. So they're saying, all right, tell me what the ordered pair would be. Well, if I do -3, this thing keeps going down forever, so eventually it's going to hit rock bottom. This one, if I come at it from the right side, this one's going to go up, so this one's going to be positive infinity. And that's that whole that's why you get that undefined message in your calculator, because this one's going this way and this one's going this way. And they're going at the same thing, but they're coming at it from two totally different angles. You know, it's kind of like me, and a lot of times, you know, I'm the math person, my wife is the language person. We look at a problem and we come at it two totally different ways. We're still trying to get the same answer, but a lot of times we're coming at it two different directions, and we've got to kind of meet in the middle and figure out exactly what we're doing on that. Let's give you one more of those. Okay, let's say your x is approaching -infinity. So now you're going to take, and the only part you got for this graph is that's coming here. You're basically chasing this part of it. That as you get closer to -infinity, this is one of those lines where, and it's hard to see based on the graph that's here, you have another line drawn right on top of the x-axis. So it's kind of like the cutoff here. This one, if they tell you what happens as x approaches -infinity, well, there's only one way you can get to -infinity, because there's not up and down. But this thing is getting really close to 0. So you have something like that. You could also do the same thing if you had done positive infinity. Just scrolling up here a little bit. If you chase this thing out to positive infinity, it's going to be the same thing. It's still getting really close to 0. It's getting right on top of the line. Okay, so that's where they're trying to get you to think about, and that's why the calculators, when you do those problems, that it gives you the error message, because you've got it pushing in two different directions. It's kind of like when you flip the magnets over and you push them at each other and they try to jump off. Same thing here. It's trying to do two things at one time, and it says, no, we can't do that. We've got to actually find one common ground here. Okay, so here's what we've got to do. Got to tell you what a vertical asymptote is and exactly how to find it. Well, we already told you. Just didn't say it here. So vertical asymptotes. This is where your denominator is going to equal 0. So the same thing we had for the excluded values, that's going to be your vertical asymptotes. So take the whatever it is in your denominator, set it equal to 0, and there you go. Got which numbers you're looking for. This is kind of ties in, but it's one of those things a little different. If you have a part of the fraction that can simplify, or let's say you could cancel it out. Let's say you had x plus 2 on top and an x plus 2 on the bottom. Then if you get part that actually gets canceled out after you factor it off and you're finding the asymptotes and everything here, that if you have part of that fraction that can be canceled out, that value is a hole on the graph. So, and there's sometimes when we're doing these that you actually have, and again, I don't think they focus on this too much. I think they deal mostly with the asymptotes. But there are some times where you'll have a problem, and then you'll have just an empty hole, and then it runs off and does something like this on the graph. Kind of weird because it's everything else is perfect up to that point. You can definitely tell what happens on this side or that side of it, but it's almost like, back here you could almost have a hole in the middle of a graph right here. That this thing works perfectly. We get right here, oh, that didn't quite work out, but everything else on either side of it would. It's not it happens every now and again, and again, I don't know that they focus on it too much, but just in case they throw that out there about finding the holes, it's where that basically it would factor out everything. Okay, and then let's get the horizontal asymptotes. Let me go to the next page. Horizontal asymptotes are a little bit longer. Because this is more of a comparison kind of thing. It's not just do this one thing and you've got it. Horizontal asymptotes are basically based on this. Let's say that your numerator degree if I can write here. Okay, so let's say your numerator degree is n, and your denominator degree is m. Because it comes down to comparison on this one. It's not just, here's what's happening. This is when you have to compare whatever your highest degree is in your numerator based on the degree of the denominator. And you've got your three options. You've got your numerator degree is less than the denominator. So let's say, you had x to the third on top and you had x to the first on the bottom. Kind of what we're looking at. If your reverse that. Set it backwards. If it's like this, where you've got x on top and x to the third on the bottom. Okay, and just so we don't have to write horizontal asymptote like a million different times. just put HA, just make it go faster. So if the numerator is less than the denominator, then the horizontal asymptote is going to be at y equals 0, which means it's going to be right on top of the x-axis. Okay, so that's one of those good ones where you don't have to worry about it, because if it's right on top of it, or if the numerator is going to be less than the denominator, if we're doing x over x to the third, something like that, then it makes it easy. It's right on top of the x-axis. Just draw a line right on top of it, kind of like the previous problem we had. Okay, if the 2 degrees are the same, if you've got x squared on top and you've got x squared on bottom, then the horizontal asymptote is that y equals the leading term coefficient. I'm going to put it in here because I'm not going to get it in there. So it's going to be at the leading term coefficient of the numerator divided by the leading term coefficient of the denominator. So because they're basically the same, they cancel each other out, and whatever's left over your coefficients, that's what you're going to get. Okay, and the third option, which they kind of throw this out here to you and then they leave it. There's actually one other thing that they do if it's the numerator greater than the denominator. Then this one, they kind of give you a break on this one. There's no horizontal asymptote. Now, here's what you actually would have to do here's what happens in the rest of the section, but they don't actually get to and have you doing this one. There's not a horizontal asymptote. You've actually got a slant asymptote. This would be a problem where you'd have to go back and do synthetic division, find out what the answer is, and then once you find the equation at the end of the synthetic division, that would be your slant asymptote. And then it takes up a degree of difficulty, and they say, okay, for now, don't worry about it. If numerator is greater than denominator, there is no horizontal asymptote. That's as far as we're going to go. Okay, so here we go. Let's give you a problem where it asks you to do all these things, and then we'll actually come back and graph one here in just a little bit. Now, and some of the problems that they'll do, they'll actually do it where you only have to find the vertical asymptote. Next problem is you'll find the horizontal asymptote. They'll have you practice a couple of those, and at the end they'll come back and say, all right, now do everything. We're going to find the vertical, horizontal asymptotes. We're going to find the graph of the function, do all these things. We're just going to go ahead and kind of do them all at the same time because we can break it up in pieces, but most of it, if we do one, we'll just do the whole thing. We may not do the graphs on a couple of these just to kind of speed things up. We'll see. So let's go 4x over x minus 2. Okay, so very first thing we've got for the vertical asymptotes, that's just taking your denominator equal to 0. That one's pretty straightforward. Add the 2 to both sides, we've got x equals 2. Okay, for the horizontal asymptote, you've got 4x to the first over x minus 2, and again that's x to the first, so your numerator is degree 1, your denominator is also degree 1. So when you compare those two, the numerator equals the denominator. So basically we're looking at option 2 back up here, which means then we're just going to compare the leading terms. So we're going to compare 4 to 1. So if you've got 4 over 1, that's just 4, so that's going to be y equals 4. Okay, so vertical asymptote, pretty straightforward. Take the denominator, set it equal to 0. Horizontal asymptote, it depends on what these powers are. You compare this degree to this degree, we got less than, greater than, or equal, and we'll go from there. Now, the good thing is when you're graphing these, you will not have to worry about graphing one that's this way, because that's a slant asymptote. They don't tell you how to do that. It's just a spin off of syntactic division. So basically when you're graphing these, it's either going to be one of these two, because we're not going to have the slant asymptote part of this one. So it's either going to be they're equal or this one's going to be less than. And the way this thing is setting up, that's going to go for it. Now, here's what we've got to do, or here's where we'll kind of graph it. Because we haven't told you how to graph it, but we'll go ahead and do it here. X is equal to 2 and y is equal to 4. Alright, x equals 2, 1, 2 will be here. And y equals 4 will be about 4. Here. That over just a bit. Okay, now here's, and again, this is another one of those where this is kind of screaming for a multiple choice kind of question. Because what you're going to have to do is basically this is where it comes down to guess and check. That you have to check to be able to graph on these. I'll put this underneath it here. We've got to plug in or evaluate. You've got to plug in or evaluate a number to the left and to the right of every vertical asymptote. Now, and here's what you do when you do that. You are looking for a number, but really you're looking for, does that number, because basically here's what it is. Unless it's a special case where you do get some factoring, sometimes you get some that are factored out and cancel. But for the most part on these, you cannot touch these asymptotes. They're kind of the cutoff. If let's say you got arrested and they said you cannot leave Limestone County. Okay, that's it. That's your borders. That's the line that's on here. You cannot go past that line. Same thing here. So they tell you that this is like your borders. This is as far as you can go. So if you get a graph that's here, this is as far as you can go here, or this is as far as you can go here. That's your cutoff lines. Now again, occasionally there'll be some that you may get a problem where it may factor out, and you may have a hole right here in the middle where you can go through it. But for the most part, you're not going to be able to touch those boundaries. Once you hit them, that's it. You got to stop. That's as far as you can go. So all you're trying to do on this one is when you pick a number, let's say in this case, if we pick a number to the left of 2, well, that's 1. Pick a number to the right of 2, that's x equals 3. Because our vertical asymptote, we only had 1, so we were at x equals 2. So you got to pick a number to the right of it, to the left of it. Plug that number back into the function, which is 4x over x minus 2, and see what happens. and that's going to be your Y value, and that'll give you an ordered pair. That one ordered pair will tell you basically, okay, am I cut off by Lauderdale County or I am Limestone County? And you got to figure out, because you're only going to be one of those two. You're either here or you're here. You know, let's say you're wanted in both counties, and somebody arrests you first. You're figuring out who's arresting you first at this point. So here, am I staying here or am I going to stay here? Okay, so plug in 1 and see what happens. So that's 4 times 1 over 1 minus 2. That's 4 divided by negative 1, which means that would be at negative 4. So if I plug in the value of 1, that's going to put me at negative 4. And all you're going to need for that point is, okay, where does that go in that first region? Am I above the line or below the line? 1, negative 4 would be down here. So that means you're cut off and you're stuck in this area over here. So that graph is going to have to look something similar to that. So all this point does is just tell you, all right, which region am I in? Basically which quadrant am I going to be in? Because you can't be in all of them. You can only be in part of them. So you're either here or here, or you're going to be here or here. And then we'll do the same thing with x equals 3. We'll plug it in and then see what happens. That's 12 divided by 1, so that's going to put us at 12. So that ordered pair would be at 3, 12. And again, if you plot that point on the graph, 312 is somewhere way up here, and you don't really care. You just know you're above the line. So that would also put that graph somewhere like this. Okay, and again, I'm pretty sure when you're doing these, the ones that I know, the test questions and seem like the online homework questions, they always give you multiple choice when you get here and have you do all these things. And it's that same thing. They could give you a graph where you've got this part here and this part here. Or you may have one here and one here. Or it may be that you've got one here and one here, or one here and one here. Or they may change it where that they put this one at 4 and this one at 2. So you just got to find the numbers and kind of basically play the matching game to kind of figure out exactly how it's going to look there. But find your vertical asymptotes, find your horizontal asymptotes, lay those out, and then from there just plug in numbers on either side of it, and it basically puts you in a quadrant, and you figure out, okay, if I'm on this side of the line, am I above the line or am I below the line? And that's all you're really worried about. Now they call it I think in the online homework they call it a 7-step method, because you're finding the vertical asymptotes, the horizontal asymptotes, you're finding the domain, you're going to plot the values, you're going to do all these things. Basically, it's a 7-step method, but you don't have to do every single step. Okay, for example 2, we'll go 2 over x squared plus x minus 2. Alright, first thing is vertical asymptotes. Again, take that denominator and let it equal 0. And again, this one you can factor, should be a pretty straightforward factor, because the only way you can factor 2 is to get 2 times 1. And since the b term is positive, the bigger number has to be positive, and the smaller number would have to be negative. Setting both equal to 0. Now in this case we've got 2 vertical asymptotes. So now we've got to plug, every time you get a vertical asymptote, you've got to plug in 2 numbers. The previous problem we only had 1, so we plugged in 2 numbers. This time you've got 2, now you've got to plug in 4 numbers, because you've got to check around each one and see what's happening. Okay, and for horizontal asymptotes, in this case, your numerator is degree 0 because there is no x. Denominator is degree 2. And again, if you're graphing these, for what we're doing right now, it's either one of the two options. In this case, your numerator is definitely less than your denominator. So that means we're going with option 1, where by default it's going to be at y equals 0. So if they ask you just to find the horizontal asymptotes, they don't ask you to graph. All three options are on the board, but if they ask you to graph, it's only going to be one of the first two options, because they're not going to give you a problem where there are no horizontal asymptotes, because technically there's a slant asymptote, but they're not asking you to find that. So these, it's either option 1 or option 2. Okay, so there's everything we need, and just a quick sketch of it to get the asymptotes in. There's our XY axis. We need we'll do them all in green here. We need one at -2. We need one at +1. And then the other one is right on top of the x-axis. Okay, now the same situation is still going to go when we plug in -3. Now, if you want to pick 2.1, that's fine. But I would say go whole numbers because it's easier. We're going to plug in -3, and we're going to see, does that number put me below the line or does that put me above the line? And that's all you're worried about, because it's either going to be here or it's going to be here, because you're cut off. That's as far as you can go in those corners, and we just got to figure out which one it's going to be. Okay, so plug in -3. Back up here, and let's see what we get. We get 2 over x squared plus -3 minus 2. Okay, so that is 2 over 9 minus 3 minus 2. 9 minus 3 is 6, 6 minus 2 is 4. Now, it's not very big, but we get a half. So that order pair is at -3 and 1/2. But again, more worried about where it is, that's going to put us up here above the line. So not very much. It's going to put us somewhere about here. But that's all we need is that one point. Know that the rest of the graph is going to fit in and do something like this. Okay, for this line, I would say let's go with x equals 1 to see what's going to happen to the right side of the line. We've got 2 over 1 squared plus 1 minus 2. Wait, no, that's not right. Yeah, that's right. So that's 2 over 2 minus 2, so that's going to be 2 over 0. That's undefined, right? Okay, so here's that part where we get a problem that says, all right, for this one, that doesn't really work. So if we put this point in right here, we got a little bit of an issue. So that would be a gap that we got here. Now, here's one of those things where they say, all right, here's one of those little special cases where this thing happens. If you get one like this, because there's nothing that's going to factor out or cancel on this one, this is one of those things where if it's in the middle of the graph, that sometimes you can change and go from here to here and it's okay. Basically, that point's right here. We still don't really know what happened because this one fell right on the line. So that's all right. That one we would have to go back and put in 1.5 because we put in 1 and it didn't do it. It fell right on the line. So that point doesn't help us any. We've got to put in. Wait, that was +1, right? Okay, that should have been a -1. All right, so let's go back and change that to a -1. I was like, something's not right here, because that shouldn't have done that. Yeah, sorry about that. So that's -1 squared, which is 1. 1 plus -1 is 0. 0 minus 2 is -2. Okay, sorry about that. I'm paying attention to my signs there. So that is -1. Okay, so that's a little better. So we plugged in the point -1. We got -1. So that point would be right here. Yeah, I wasn't paying attention to my signs there. Because that was our value. We had at 1. We had the asymptotes over there. Okay, so this point was at -1, -1. So that point would have been about here. So again, that's below the line. So this graph would look kind of like this. Now, here's the thing, that even with this one, and kind of got ahead of myself there, sometimes you can cross over here and come back up this way, or it may come up here and just loop and turn back around. If it's in the middle of the graph, and that's where those holes would come back into effect, that sometimes you'll get some things that'll cancel, you'll get a hole, and you can actually kind of skip over it and go through it. This one more than likely is going to turn and come back here, but let's just double check it just to make sure. Let's plug in 0 and make sure what's going to happen, because now we've picked these 2 points on either side of the graph. We've got to do the same thing here, because if we plug 0 in, it possibly could be back up here. If it does, that means we've got a graph that's going to go like this. Or if it's negative, well, it's just going to turn and come up here and get close, and it's going to come back. So the middle, you get those options where you actually can cross through the middle of the graph and come up to a point up here. But most of the time, if you're going to do that, you're going to have a hole where that you could cancel some things here. I don't think it's going to happen here, but we'll just double check it just to make sure. Hopefully well, 0, I can't mess up the sign on 0, so we'll be okay. So plugging in 0, we'll get 2 over 0 squared is 0. Got another 0, so that's 0. That's a -2. So that's 2 over -2, which is -1, so we're right back in the same spot here. So we plug in 0, we're back here. So it loops, comes back, and does something kind of like this. Now again, if that had been a positive 1, then we're back up here. That graph would have gone through like this and cut over, but it was negative, so it stays below the line. And then one more point. We've got to go out past the 1 and see what happens at 2. So we've got 2 over 2 squared plus 2 minus 2. That's 2 over 4 plus 2 minus 2. Well, those are canceled, so that's 2 over 4, so that one's also at half. So that one will be just a little bit above the line, which means everything will be just a little bit above the line there. So the more asymptotes you get that are vertical, the more plugging and chugging you've got to do. That's probably the worst part of the problem is just the plug and chug part, because there's no real shortcut to going through those. All right, one more. Was that good? All right, let's do one more. Just we've got a little bit extra time, so. And again, to me, it's not the asymptotes that's the hard part. It's just the plugging in the numbers, because that is the worst part of this thing when I see these. Especially if you got your checklist out in front of you to go back and figure out, what the vertical asymptotes are and what the horizontal asymptotes are. That part's not bad. It's just, to me, it's plugging in those points that gets to be long and aggravating here. Okay, this one's kind of good because on the bottom we've got x squared minus 4. You've got a special kind of factor in there because you've got the difference of 2 perfect squares. And just remember that you've got to square root both of those. So the square root of 4 would be 2 and 2. Just going to make one positive and one negative. Which means when you solve it, it's going to still be the same thing. We're going to have a positive 2. We're also going to have a negative 2. Alright, for horizontal asymptotes. Numerator is degree 2. Denominator is degree 2. So in that case, they're equal. And when they're equal, you go back and look at the coefficients, which in this case was 1 and 1. well, that's still just going to be 1. So we've got 2 vertical asymptotes and 1 horizontal asymptote. Okay, so to me, that's the easy. If there's an easy part to these, that's the easy part. Here's your vertical asymptotes, and again, it should be pretty straightforward. Horizontal asymptotes, you're just comparing your powers. In this case, the powers are equal, so you look at the coefficients. They're both 1s, which means it's just going to be 1. So x-axis, y-axis. This one will be at -2. This one will be at +2. And this one is going to be just above the line. We're going to put that at y = 1. Okay, again, to me, this is the long part of it. We're going to go back and plug in numbers we got to plug in -3 and then -1. Over here, we're going to plug in, make sure I get my signs right this time, +1 and +3. Now again, you could stretch these out. If you want to go a little farther out and get 4 or 5, same thing here. If you want to get -4 or -5, you could do that. In the middle, though, I would take the next number, just for simplicity, I would say pick the next whole number to the either side of it. Don't go too far out, because if you get, especially in the middle, if you get too far away from the middle, it can throw your numbers off because of just exactly how it's set up there. Alright, so let's just put all the work down below it so we're not squeezing here. So we're going to do -3. So that's going to be -3 squared plus -3 minus 12 divided by -3 squared minus 4. Sure I have that written down right. Yeah. Okay, so that is 9 minus 3 minus 12 over 9 minus 4. 9 minus 3 is 6. 6 minus 12 is -6 over 5, so that's a -1.2. So -3, -1.2. So -3, -1.2 would be down here somewhere, so that one's going to fall something like that. Definitely below that horizontal line. Okay, and keep working. We're going to do the same thing for -1. So it's -1 squared plus -1 minus 12 divided by -1 squared minus 4. So that's 1 minus 1, which will just cancel. This is 1 minus 4. So that's -12 over -3, which is 4. So we plugged in -1, we got 4 for an answer. So that one's going up top. That one's plugged in -1, that's 4, that's somewhere way up here. So we know that graph is going to come in and do something like that. Now again, there's a possibility that it could go through and then come down this way, or it's going to turn here and come and go back up. That part we don't really know. And again, if it cancels out, if we factor this, you would have x plus 4, x minus 3. This one we'd have x plus 2, x minus 2. Nothing factors out, so there's probably no holes. But sometimes you also can tie in that if you have some x-intercepts in the middle. If you have an x-intercept here, that it possibly could come in and turn and go down this way. You have a y-intercept, kind of the same thing. So there's all kinds of possibilities. It's either going to turn or it may go through. You don't know until you just plug it back in. You could actually dig into it a little bit deeper, but they don't make you do that, so we're not going to make you do that either. We're just going to plug and chug. which again, it's not the best thing in the world, but that's kind of our only option here. So x equals 1. Same thing we had here, but just got to change the sign. So it's 1 squared plus 1 minus 12 over 1 squared minus 4. So that's 1 plus 1, which is 2. 2 minus 12 over 1 minus 4. That's negative 10 over negative 3. And that's a positive 3.3. So that's at 1 and 3.3. Which means that's somewhere up here. So this one's going to turn, come back up something like that. So 1, 3.3 was somewhere up here, kind of like this point, somewhere up here. And then the last one. X equals 3, which will be the same as here, just change the signs to positive, so that's 3 squared plus 3 minus 12 over 3 squared minus 4. That's 9 plus 3, which is 12 minus 12, which is 0, over 9 minus 4, and it doesn't matter what 0 is, 0 or anything is just 0. So that would be the point at 3, 0. So 3, 0 is here, so that's going to put us somewhere like this. Okay, so again, just the worst part is this. Just plugging in the numbers and working through it, because we got the horizontal asymptotes, or horizontal vertical asymptotes 10 times faster than we did just to plug all this stuff in here, because it's just not fun, but that's what you got to do.